Let's give a few examples of end devices that can be used for developing and prototyping purposes. Starting off with the Things node, which is developed in collaboration with the Things Industries, Tweetonig and Microchip. It is an Arduino compatible device with an embedded LoRaWAN module, embedded sensors and a PCB antenna, all put together in a waterproof casing. So we screw open this device. It looks like this. Let's go through the components. First, the MCU, which is a small Atmel chip called the Atmega 32U4. And at the back of the device, there's room for 3 AAA batteries, but you can also add a power source via a micro USB connector. So there are several peripherals that are added to this device, including a button, an LED, an accelerometer, a temperature sensor, and a light sensor. All very tiny and embedded on this PCB board. Then we have the LoRaWAN module, which is in this case the Microchip RN2483, optimized for the EU868 frequency. In this LoRaWAN module is the Semtech chip, as well as a small MCU that runs the LoRaWAN stack. And finally, we have the antenna, which is embedded on the PCB board itself and is directly connected to the Microchip LoRaWAN module. Another example is a node which I built myself. I started off with a small Arduino, which again has an Atmel chip as an MCU. To provide it with power, you can connect 2 AA batteries. You connect them to the 3.3 voltage and the ground pin. You can also provide it with power using these input pins. So I can attach a temperature and air pressure or barometer sensor via these so-called I2C pins. Also, an LED is attached. And for this node, I'm using the RFM95 LoRa module, designed by Hope RF. In contrast to the Microchip LoRaWAN module, this one does not contain an additional MCU. So the LoRaWAN stack runs on the main MCU of the device. And I use the IBM LMIC library for this purpose. Finally, I added a wire of 8.2 centimeters, which is exactly a quarter of the wavelength of the 868 MHz frequency. Everything is soldered on a small PCB board, which connects everything together. A third example is the LoRa Discovery Kit, designed by STMicroelectronics. The MCU is developed by STMicroelectronics itself. On the back, there are 3 AAA batteries that can be connected to the boards to provide it with power. So this board has a very tiny LoRaWAN module, which is developed by a company called Murata. In this tiny module, there is a small MCU that runs the LoRaWAN communication protocol. As you can see, the antenna is present at the top of the board. So apart from some LEDs and some buttons, this board does not contain peripherals, but additional sensors can be added simply via these pins you can see here. For example, through a shield. With me, I got an extension board with an accelerometer, gyroscope, temperature, humidity and a pressure sensor that can be easily added to this board. So these examples shown are meant for developing and prototyping purposes. A developer or a device maker can always start with a development board to quickly build the functionality before large quantities of end devices are being manufactured. For the development boards, there are several options available. One of the most commonly used one is the Arduino board. The Arduino boards are quite easy to program and have a large global community of hundreds of thousands of people. I recommend you to get started with an Arduino board while you're building your first LoRaWAN use case later on during this course.